All right, so here biologists have found that the weight W of a bird and the length L of its wingspan are related by L is equal to K times W to the one-third, where K is a constant. The following table lists L and W for a species of birds, and we're supposed to complete parts A through D. So this is our table, and so we're supposed to find approximate value of K. So let's do two versions this time. So we have L, so that's going to be 0.395 equals k times 0.1 to the one-third. So we divide it by 0.1 to the one-third, divide by 0.1 to the one-third. And let's also do the other end. Let's do 0.877 is equal to k times 1.1 to the one-third. So we're going to divide by 1.1 to the one-third and divide by 1.1 to the one-third. Okay, so we have that now. So let's do those two calculations and see if to two decimal places, whoops, uh, we have what we're looking for. Let's clear that out. Let's clear that out. So we have the first one we had 0.395 divided by zero point 0.1 to the 1 divided by 3. So it gives us 851. And the other one, we had what was it, 0.877 divided by 1.1 to the 1 divided by 3 and 0.85. So to two decimal places, we have basically the same thing. So this is, approximately 0.85, and this is approximately 0.85. So that works as far as the same numbers. Now we're supposed to graph L and the data using the same viewing rectangle. We're supposed to choose from the best ones. Well, zero point 0.1 is 0.395, so this is 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be half. So that's going to be zero point 0.2. So at zero point 0.1, we're about zero point 0.4. So that's big dots. So that would work. That one's not going to work because it's too high. That's right at the height. No, that one is a little high too. Plus, it's going down here, so that one's not going to work. So it has to be this one. Okay, so that's going to be what happens as it increases. So what happens to L as the weight increases? The length increases as well. Now let's go to our calculator and plot all of those points. Okay, so let's go back over here. Let's go to here and clear those out, clear those out. And so when we do that, what we're going to do is we're going to plug in, and we had zero point 0.1, then we had zero point 0.4, then we had zero point 0.8, and then we had 1.1. Okay, then we had the 0.395, and we had the 0.626, and then we had 0.789, and then we had 0.877. And our window, well, these are both. So X's, we're going to maybe go up to 2. Let's go by zero point 0.5. The Y's, we're going only to probably zero point 0.1. Let's make sure we don't have anything here because that's not going to be what it is. So that's what our graph looks like. And so that really does match this one the best. Okay. Now, this is going to be our formula. So now it's going to be 0.85 W to the one-third. So let's go back over here. That's going to be 0.85 X to the 1 divided by 3. And it looks like it fits pretty well. Okay, so that's the key pieces that we need. So, that would go through here. So now we have this page. Now part this one. Find the wingspan of a 0.95 kilogram bird. So now we have 0.95 here. So we're going to have to take, excuse me, uh, 0.85 times 0.95 to the 1 divided by 3. Now we'll plug that to our calculator. So 0.85 times 0.95 to the 1 divided by 3. And we get about 0.84. Oh, how many decimal places do they want here? 3. So that would be 836. So that would be 0. 0.836, and it's going to be the wingspan is in meters. Okay, so that's going to be that solution. And so now, what if we have W is 0.65? All right, so, well, now we're just going to plug that in. So it's going to be 0.85 times 0.65 to the 1 divided by 3. And so I'm going to say, well, let's cheat here. And because we're only going to change that from a 9.5 to a 0.65, and we get 736. All right, so interpret the result. The wingspan is 0.736 meters when the weight is 0.65 kilograms. Okay. Now, let's go to our calculator and see what we have. So we want 0.95 and 0.65. So let's go here. We want a value. We want 0.95. 836, close enough. What about 0.65? 736. Close enough. And it shows you kind of where it was on the graph, and it falls right on that line. And so I would say, with our calculation, it looks pretty good, and with that, it looks pretty good there. So those are the solutions that they're asking for here to three decimal places. All right, so that's all I have. So hopefully that helps.